Good afternoon, everyone. Thanks, Norel, for this introduction. I would like to use my time to explore with you how technologies, both traditional and also digital ones, can strengthen our food systems in the face of the accelerating climate change. This is the thing, right? Okay. Yeah. Okay. Yeah. So, we just heard our food systems are under immense pressure. We have droughts, floods, wildfires, everything fueled by climate change. And this is declining our global harvests. Just this year, Germany saw its driest spring in a century. And at the same time, we have wars in Ukraine, in the Middle East that also disrupt the global grain supplies. So this map here is somehow forecasting what could most likely happen in a couple of decades if we are not changing our habits. So the Intergovernmental Panel for Climate Change used this climate scenario assuming that we will still continue to rely on fossil fuels and that global temperatures will increase by 2 to 3% until 2100. And the study concludes that over 50% of the people in the most vulnerable regions may be undernourished by 2050. The figure on the right side is illustrating that the number of people facing severe hunger and food insecurity has more than doubled since 2016, with dramatic populations in Sudan, Gaza, and also Haiti, Mali. Beyond being affected by climate change, agriculture is also a major driver of it. Agri-food systems account for about 1/3 of the global anthropogenic greenhouse gas emissions. Also, global meat supply is still increasing from about 40 kgs in 2012 to 45 kgs per capita in 2022. So you see, agriculture is both being harmed but also causing environmental stress and thereby also contributing to push the planetary boundaries. If exceeded, this could then destabilize our Earth system, and this then leads to irreversible environmental changes. The excess in nitrogen and phosphorus, for example, can lead to eutrophication. And these excess nutrients in water bodies, they cause excessive algae growth. And this algae growth is then depleting the oxygen in water and harms aquatic life. We have seen that just recently at the Mexican Riviera Maya. You can see a picture there. With very excessive seaweed growth affecting not only the marine organism, but also the tourism there, which is the major income in that region. Let's zoom into soil, because that's my topic. Soil is often overlooked, but absolutely vital to combat food insecurity. A total of 33% of global soils are moderately to highly degraded as a result of erosion, of compaction, pollution, acidification, salinization. And most of the soils today fall short on their optimal organic carbon levels. This weakens their productivity. It increases the risk of erosion and also worsens the water stress for crops. In the European Union, 83% of agricultural soils contain residues of pesticides. About 1/3 of the land suffers from unsustainable water erosion, and another 23% of land is harmed by subsoil compaction caused by very heavy machinery. In contrast, healthy soils are resilient. They retain water, they reduce emissions, they support biodiversity. But having a healthy soil requires not just awareness, it demands action and investment into technologies. Healthy soils under agricultural use represent in my opinion, the key in decreasing food insecurity, mitigating climate change, and also stabilizing our planetary boundaries. What do I mean when I say technologies? Technologies in agriculture range from very traditional knowledge on crop rotation to also advanced digital knowledge like agricultural robots. From data to tools to practices, these technologies have to lead us towards resilience. Otherwise, they don't make sense. But they also must be adopted by many people, and they should also be inclusive. This requires comprehensive efforts for capacity training, for knowledge transfer, and often also for economic incentives for farmers. In the following slides, I would like to show you a couple of examples for technologies used and applied around the globe and how they can help us to increase food security and agricultural resilience. Crop rotations appears to be an old hat, but still is the most important technology we have in agriculture. But we also know that the number of crop species globally is decreasing. Niche crops are rarely being produced, and farmers simplify their crop rotations. In single regions, we see that they also have intense monocultures. Crop rotations are important because they break soil disease cycles, and crops with different root systems that you can see there in the picture can also take up nutrients and water from different depths, like shown here with the perennial wheat. Certain crops have even deep compacting functions, so they decompact the soil like tuber crops, or they leave nutrients in the soil like legumes. Crop rotations with leguminous pastures, like implemented in the Pampas region in Latin America, generate soils. They boost their fertility and they cut pesticide needs. Traditional systems like the milpa is used in Mesoamerica to produce crops like maize, beans, and squash simultaneously without employing pesticides or additional fertilizers. Spatial diversification practices like strip cropping here on the right picture, also called relay cropping, intercropping, mixed cropping, increase water use efficiency and stabilize yields. And those diversification practices also reduce production risk for farmers and diversify their income. Conservation agriculture is another known technology where soil tillage, the movement of soil with machinery, is minimized, and where we leave crop residues like straw after harvest on the soil surface to protect the soil. And we have to rotate crops. And this reduces erosion, retains soil moisture, and also lowers the required machinery inputs for fuel. Another cropping system technology are agroforestry systems. We heard now about the role and importance of trees. Agroforestry is mixing trees with crops and or livestock and can work as a water smart and biodiversity enhancing and even economically diverse way of farming. The trees in the cropping system act as shields against wind erosion, create shade, and then change the microclimate of the crops, which even supports pollinators. Let's dive into technologies. Digital agriculture technologies applied in precision farming use satellite and drone information, GPS, and artificial intelligence to target the water, fertilizer, and pest control according to the crop's needs. This can happen at the field scale, at the management zone, or even already at the plant scale. And those precise decisions made by machinery and the farmer save resources, maximize yields, and minimize environmental hazards like overfertilization. Agri-photovoltaic systems, that's maybe something new. A more recently tested cropping system technology that allows us to grow food and to harvest solar energy at the same land. Elevated or vertical panels provide shade or protection against extreme weather events like hail, reduce water loss, and allow the cultivation of marginal lands. Flower strips could then, for example, be planted directly under the panels and even provide habitat for insects and pollinators. Agri-photovoltaics can be used for grassland, also crop production, and there are already several examples and options available. In Germany, the regulations for agri-photovoltaics allow a maximum of 10% for energy production or panel coverage, leaving 90% for production purposes. If digital technologies are combined with crop diversification, we obtain a design of cropping systems that can increase diversification at the spatial, temporal, and also genetic scale. And in those new field arrangements that you can see on these pictures, like spot farming, pixel cropping, agroforestry, agri-photovoltaics, not only the fertilizer or plants are adjusted to the local conditions, but also we select crops regarding their site-specific needs. But you can imagine, as field sizes and diversification is increasing, we also substantially increase the complexity of those systems, which is then very difficult for farmers to manage those complex systems. And farming already involves working long hours with very few breaks during harvest, for example, and many farmers face high levels of stress and fatigue. So how can we manage this complexity in order to get our sustainable systems? One of the solutions that I'm investigating is the use of autonomous field robots to manage those complex, diversified cropping systems. Agricultural robots now perform already activities like weeding, planting, even harvesting, and reduce the reliance on pesticides, on human labor and fossil fuels for tasks that are very repetitive and time-consuming, like, for example, mechanical weeding. And robots allow farmers to scale sustainable practices. Although still in its very early stages, the agricultural robotics market is rapidly evolving. Startups are introducing increasingly versatile solutions, ranging from very task-specific tools to modular, Lego-like tools that can adapt to different crops and also interventions. A significant impact on global markets is expected within 20 years, where autonomous machines can already play a relevant role in farming. Nature-based and digital solutions together give us tools to deal with climate change and food insecurity. The technologies exist, and we have also built a lot of knowledge. But the adoption is still very low. And now it's up on us to rethink how we actually want to produce food. The bioeconomy lens helps us to see agriculture as part of a bigger circular system. And we are not just talking about food, we also talk about energy, soil, biodiversity. That all is part of the big puzzle. It's important to point out that the real change only happens when farmers, researchers, policymakers, tech developers, companies work together on the ground, in living labs. And in my opinion, that's the only way how we can build systems that truly last. Thank you.